Okay, question 7a from a paper 5 from, 2023, I think. Find the number of different arrangements of the 9 letters of the word delivered in which the 3 E's are together and the 2 D's are not next to each other. Let's approach this in 2 ways. The one is just following it directly. The 3 E's are together. Okay, if they must be together, let's put them together as one object. In other words, we may as well just consider this as one E in some ways, or another letter entirely, but the 3 E's are together. So in that case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it says 9 over here. And we got rid of the 3 E's and put them together. So, but think how many objects we've really got now if the 3 E's are together. Well, we've got those 3, we've got 6 others, so there's 7 altogether. Now, we want to do everything except the D's. So we've got an L, an I, a V, and an R. There are 4 others. And what we haven't got quite yet is the 2 D's, right? 4, 5, 6, 7, 8, 9. So we've got these 1, 2, 3, 4, 5 objects, and we're going to place them where order is important. So we've got permutations. So 5p5 or 5 factorial. Now let's put the D's in. Now the D's must not be together, so they can be any of these spots over here, and they'll be quite happy because there'll be something between them. And of course those E's had to go together, so here there'll be 3 things next to them. So for our D's, we can choose any 2 of these 1, 2, 3, 4, 5, 6 places. So after we've got our 5p5 ways of doing these 5 objects, what we're then going to do, we're going to do, is choose from those 6 spots, we're going to choose 2 to put our 2 D's. And we get whatever our answer is, 1,800. Okay, so that's option 1 of looking at it. Now option 2, I always think it's interesting if you've got the time to go through the different ways of doing these, because in one time one will be easier than another one, and then it also just develops your thinking in a lovely way. So let's do it where our E's are together, because they definitely have to be together. And we're going to place it in this, all the letters, V, R, and there are 2 D's. Not together, just that. So that's the total number of ways we can arrange all of these, which is 1, 2, 3, 4, 5, 6, 7 factorial, but the D's are repeated. There are 2 of them. Remember, these E's we're treating as one object. So there's 7 objects, 2 of which are identical. And let's subtract the options where the D's are together. Well, in that case, if the D's are together, we've now got 1, 2, 3, 4, 5, 6 objects with no repeats. So 7 factorial over 2 factorial is all the options, minus 6 factorial where the D's are together. I think this is a case of 6 of one, half a dozen of the other, because both of them are lovely ways of thinking about this. So yeah, take your pick which one you like. Both of them get you the right answer. Both of them are lovely mathematical thinking. So that's 7A. 7B's coming, and then of course after that 7C.